but it could also be a sign that HCFC 22 exports from China are being intentionally misdeclared upon import as non-ODS alternatives, or they may be diverted to other countries so they never actually reach their intended import destination. I want to touch on a few recent cases of CFC seizures. In China, there was a Chinese television investigation earlier on in the year into the aerosol cans that are available on the Chinese auto trade market. And these are HFC 134A cans. But when the investigators tested the cans, of the 12 they tested, only 2 contained 134A and the rest contained CFC 12. And they estimated that about 80% of all such cans on the market could contain CFC 12. In the Philippines in 2012, a company called A Fresco was found supplying fake HFC 134A to the shipping industry. When tested, it was found to contain more than 90% CFC 12. Also earlier on this year in the Philippines, customs seized 110 cylinders of banned refrigerant, including CFC 12. In Russia, earlier this year in January, more than 1,500 cylinders of CFC 11, CFC 12 and HCFC were seized, and these had been declared as ethylene glycol and HFC 134A. So I think there's 2 very startling things coming out of these cases. One is this ongoing CFC problem, and I suppose the question which arises is, where is this coming from? It seems to be very abundant still. We wouldn't expect to see that. Could it be that there's very large military stockpiles that are being diverted, or is there perhaps some new production? And it's certainly something that we feel needs to be investigated. Also, there's this ongoing propensity of, for CFCs to be mislabeled as HFC 134A. And there's a real need for customs to really, when they see HFC 134A coming in, it needs to be flagged. I think one of the problems is that the HS code in which 134A sits is a very generic HS code and has various other HFCs and non-HFCs in it. So that's definitely something that needs to be checked before we can move on. Just want to talk a bit about a recent case of HCFC smuggling. It's perhaps not so recent actually, it's from July 2012, but it's interesting because it shows perhaps a shift in trends that we are seeing now. This case was brought together by the Spanish State Prosecution Service against a company located in Gran Canaria, and they did a large-scale investigation which involved surveillance and phone tapping, and they revealed a very big, large-scale illegal activity. And the company involved was importing tanks of HCFC 22 and declare under the loophole which said that they were allowed to sell them to fishing vessels, but it was actually decanting this 22 into smaller cylinders for sale on the black market. If you have a look at the photos on this slide, you can see the big yellow arrow. That's pointing to one of the tanks that's being offloaded from the ship onto a waiting van. And the bottom picture also shows an ISO tank delivery of suspected R22 going to the said company. This was very much a profit-driven scam, as since the EU has banned the use of virgin HCFC 22, the price has risen. The price of recycled R22 has risen to about up to €40 a kilogram. So this was again something very much profit-driven. It also shows perhaps a shift in smuggling method and really reflects a general shift in the refrigerant market. If we look at the scale of the refrigerant market these days, it's about 3 times higher than it was in days where peak CFC trade was going on. We're seeing an very big increase in the amount of bulk shipments. This is partly because it's more cost effective to ship in bulk, and also the quality of the ISO tanks and other tanks has increased a lot. speaking to industry insiders, we have estimated that about 50 to 70% of all refrigerants are shipped in large tank containers, such as ISO tanks. So I think the question is there a move towards smuggling in large tanks as well? And I think that question has yet to be answered. It's EIA's understanding that customs checking of ISO tanks and other gas tanks containing refrigerants is inadequate. And this seems to be due to a lack of awareness of how to use the handheld refrigerant identifiers to test large tanks. We have spoken to the producers of the handheld identifiers, and they have confirmed that it is possible and it is safe and it is very straightforward. Someone who has been trained to use the handheld refrigerant identifiers to test disposable cylinders would be perfectly able to do it with much larger tanks. All that's required is a special adapter to reduce the valve size. The pressures aren't really any different. The question is getting the adapter. There are some different tanks have different adapters, so if customs are finding it hard to get that adapter, one easy solution would be for them to ask the importer to supply the correct valve, as they will have it in order to decant the refrigerant back at their facility. So I think what we really need to see is an increase in training so that frontline customs officers are able and confident in checking large tanks to ensure that these aren't just being labelled as 134A and being used as a loophole to smuggle HCFC 22. So I'll just touch upon the last issue covered by EIA's report, and that is really the need to rethink how we monitor feedstock. I have here a graph which shows observed CTC emissions compared to reported emissions for 2012, and the big line on the left shows observed emissions based on atmospheric readings, and that shows about observed emissions of about 39,000 metric tonnes. If we look at the reported feedstock emissions, the high-end estimate, which assumes a very leaky feedstock process, gives expected emissions of about 9,000 tonnes. If we assume a much tighter feedstock process, we would have emissions of just 900 tonnes. So there's some 30,000 plus tonnes going unaccounted for. And the question is, where is this going? Well, CTC is used as a feedstock in the production of HFC 245FA and HFOs, but this huge discrepancy suggests that there could be some diversion of CTC onto illegal markets, and EIA's own market analysis has seen CTC openly available for sale in a variety of uses, including as a solvent. And I think it's worth remembering that this isn't just an issue of the ozone layer. This is also very much a human health issue. CTC is a very toxic substance and is carcinogenic, and therefore people shouldn't be using this product in an emissive way. So I think we need to really think about how we control trade in ODS feedstocks. It's very important to monitor the end uses, and customs really need to try and find a way of verifying those end uses. One way could be through licensing ODS feedstocks. I think we need to really think about this now and address this now, because as the HCFC phase out kicks in, we're going to see a huge incentive for HCFC feedstocks to be diverted onto black markets. So just to round some things up about what we've been talking about today. So the HCFC trade data discrepancies clearly need to be investigated. One way of tackling them could be increased use of IPIC, but clearly we need to ensure that everyone is using the most recent customs codes. I think we've also seen through the ongoing mislabeling of ODS as HFCs, we really need to closely monitor HCFC trade. Currently, 134A belongs to a HS code, which is a very generic code and it contains non-HFC products. So we needed targeted HS codes dedicated to HFCs and other common, HFC 134A and other common HFCs would be very helpful. And again, as I suggested, if we could extend the licensing system to include HFCs and HFC blends to enable them to be monitored, that would really help tackle this issue. We've also seen a worrying amount of ongoing CFC trade. This seems to be a big problem across the Asia region as a whole, and we need to try and look into where this is coming from. Is it stockpiles or is there new production? And then we've also seen smuggling in large tanks could be a new threat for the future, and there's a real need to ensure that customs are trained and confident in checking large tanks and perhaps incentivized to check these large tanks using handheld identifiers. We also need to tackle the feedstock issue. As I said, the current system is inadequate, and the situation with CTCs suggests that feedstock could be a major source of illegal ODS trade, and we need to monitor this much more closely and verify the end uses. Thank you very much. Goodbye.
Euromon presents Naturally Cool. Everybody takes chilled and frozen products for granted. They are an indispensable part of our daily diet. Chilled and frozen foods undergo a series of cooling processes during their journey from the point of origin to the consumer's refrigerator. This is often referred to as the cold chain. Many other industries rely on refrigeration. Air conditioning is also important in the private, commercial, and industrial sectors. But how is the cooling achieved? The chemistry and engineering associated with cooling processes can be complex. But the general principles of cooling can be easily explained. The refrigeration cycle consists of 4 basic components: a compressor, a condenser, an expansion valve, and an evaporator. In this cycle constantly flows a refrigerant, the blood, so to speak, that streams in every refrigeration cycle. This refrigerant can be natural or synthetic. So how long has refrigeration been in existence? Where does it come from? People have been using refrigeration to help preserve food for centuries. More than 5,000 years ago, the Egyptians used the oldest natural refrigerant in the world for cooling their food and beverages: ice. A total of 4 natural substances can be used as refrigerants: ammonia, water, hydrocarbon, and carbon dioxide. Additionally, air with its central components, oxygen and nitrogen, can also be used as a refrigerant. Thanks to its energy efficiency and excellent cooling properties, ammonia has been used in the field of industrial cooling for more than 130 years. So when did refrigeration as we know it today begin? In 1869, the American Thaddeus S.C. Lowe built the first refrigerating plant working with CO2 in Jackson, Missouri. In 1876, Carl von Linde built the first refrigeration machine using ammonia in Munich. This led to the development and construction of the first large cold storage facilities in 1881. The chemical industry moved one step forward and developed synthetic refrigerants, the CFCs, which were also applied as blowing agents in aerosol cans and insulation foams. The synthetic refrigerants were propagated as safety refrigerants because they were easier to handle. From the 1930s onwards, their use increased in new refrigeration plants. Natural refrigerants such as CO2 were gradually phased out of use in favor of the CFCs. The chlorine and fluorine in these synthetic chemicals are responsible for environmental damage, including ozone depletion and global warming. Almost 50 years after the introduction as refrigerants, the Nobel scientists M.J. Molina and F.S. Rowland warned that the leakage of CFCs into the atmosphere could result in depletion of the Earth's ozone layer. Confirmation of a hole in the ozone layer in 1985 confirmed their theory. Since 1987, The Montreal Protocol has been put in place to gradually phase out the use of CFCs and other ozone-depleting substances in all areas of industry, including refrigeration. The phase-out of CFCs has resulted in the development of new chlorine-free refrigerant fluids, which don't cause ozone depletion. These new fluids contain chemicals made from carbon, hydrogen, and fluorine. When released into the atmosphere, they contribute towards global warming. With a greater global focus on reducing the release of greenhouse gases, these new refrigerants are under review, with uncertainty over their long-term future. Since the prohibition of the CFCs, the industry has again focused increasingly on the use of natural refrigerants for cooling systems. Incidentally, the Association for Natural Refrigerants, Euromon, was also established in 1996. In recent years, investment in natural refrigerant technology has resulted in modern, safe, energy-efficient, and economical solutions. Natural refrigerants are the future-proof solution that is environmentally and economically viable. Your refrigerator already uses natural refrigerants. Innovation is essential to all fields of cooling and heating, providing exciting challenges and opportunities for the future. Join us on our journey into a natural future. Therefore, Euromon is committed to the development and promotion of natural refrigerants.
you.